Hey, what's up guys? I'm Jacob Esslinger, and I was the head programmer and team captain of 1460B up until the year I graduated. Now there are plenty of resources out there to learn RobotC, but I've decided to make a video series giving you guys tutorials on how to use RobotC to program your Vex robot. In this video we'll be going over the very basics, so let's just jump right into it. Now first off, there are two tools I want to go over. One is the Fix Formatting button, which is right up here. You click this and it will format and indent all your code so it's easier to read. You don't want to rely on this because sometimes it does mess up, but it's good to get used to indenting if you forget a whole section. You click that, indents everything. Another cool tool that's built into RobotC is the autofill function. If I start typing in motor, it autofills in. I can use arrow keys to scroll down to something else and just hit enter and autofills in. This is good when you're starting out to make sure you're using the correct syntax. The last thing I'd like to highlight is if you go up to File and open Sample Programs, it'll direct you to the file system where you can go in and find sample programs on how to use LCDs, accelerometers, multitasking, remote controls. So this is a great resource if there's something simple or something that you want to learn how to do, like a gyroscope. And it'll highlight everything that the code is doing in common. If you read through this, you should be able to figure out exactly what each part of the code is doing. It's a great way to learn. Now for the sake of simplicity, we will just be programming a simple square bot. So the first thing we want to do is go up and set up our motors. So we want to go up to Motor and Sensor Setup. Now my menus may have more tabs than yours, but that's simply because I went up to Windows and set my menu level to Super User. If you're just starting off, I suggest just leaving it at Basic. Now the first thing we'll do is we'll start labeling our motors on what they actually drive. So in our scenario, we're going to be running a 4-motor drive. You want to name something short, but also something that you can easily distinguish between them. I'll put F for front right drive, front left drive. I move down to 8 to a back right drive, and back left drive. Now we want to set them to what motors we're using. The 269s are the smaller motors, and the 393s are the high power motors. We'll use those. Now if any of these are reversed, so let's say the left, we need to reserve the left. This will vary based on what your design is, but be sure to reverse them here rather than switching the wires. You can reverse the 2 wires on the motor controllers to reverse the motors, but that can end up complicating things if you're programming down the road. Hit apply, and you notice that it will paste all this code in here. Basically what this is doing is naming your port numbers. If I were to type motor port 2, that is equal to motor F right drive. Those are the exact same thing. So whenever you type this, the code is checking to see what port that is. If you were to tell this to equal something, it would be the same as telling this to equal something. Whenever you start a new file, it gives you the task main. This is what will run whenever you start your robot. So we want to put everything we want to do inside here. Now if we want to tell this robot to go forward, we got to list off our drives, and I'm going to set them equal to 127. Now this is important. Motors have their values between 127 and negative 127. 0 means they're not moving, negative 127 is going backwards, positive 127 is full power forward. You can do any range in between negative 127 and 127 based on how fast and how powerful you want the motors to be running. Alright, so now that we have all our motors equaling 127, when you turn the robot on, it'll immediately set every motor equal to 127. Now if we were to run this like this, our robot wouldn't do anything because it immediately sets them all and then the program ends because it has nothing left to do. So we want to have it wait 1 millisecond, and we want to 1 second is 1,000 milliseconds. So now after 1 second, we want to set our motors equal to 0 so our robot will stop. So I'm going to copy and paste this down here, and I'm going to set all of them equal to 0. Now if you don't tell your motors to stop in this scenario, your program will still terminate once it reaches the end. But if you were to copy just this into your autonomous mode in your competition template, your robot would continue to drive and wouldn't stop after the 1 second because the competition template keeps the autonomous mode running. So you always want to stop your motors. You always want to set them equal to 0, even if you reach the end of your program. So this is a very basic autonomous mode. Now to create a user control, we want to create an infinite loop. So we'll do while 1 equals 1. And you want to create some curly brackets. Now if we hit fix formatting, we'll notice this auto indents, which is exactly what we want here. Now first thing I want to point out is there's a difference between equals and equals. What a singular equal sign does is takes that value and sets it equal to something. So if I do x equals 1, we are making this x value equal to 1. Now if we were to say x equals 1, we are asking, are these two things equal? Is x equal to 1? Now what we're asking here is 1 equal to 1? And yes, so this is the same as putting true, because our statement is true. But for the simplicity of you being able to see it, I'm going to leave it as 1 equals 1. Basically all this is saying is while whatever's in the parentheses is true, run what is ever in the curly brackets below it. So why do we want to create an infinite loop? If we didn't have an infinite loop and we just had it in the task main, as soon as we turn the robot on, it would run through the program very quickly and end. It would terminate, because all we're asking is to check for values. We don't want that. We want it to constantly be cycling through and refreshing and constantly checking, are we pressing buttons? Do we want something to happen? So this is very crucial in making a driver op. So this is set equal, and this is comparing. Now first thing we want to do is we want to list off our motors. So we'll start with the back left, and we're going to set that equal to vex RT. Now if you look on your vex joystick, you'll notice some arrows and numbers. This is telling you what number the axis is. Now we're going to do a thing called a tank drive. And what this means is the left side of our robot will be on our left joystick and the right side will be on the right joystick. Now up and down on the right side is channel 2. Up and down on the left is channel 3. So we'll do channel 3 since this is a left motor. Now we will do the other. We'll do the front left. And we'll have that equal to vex RT channel 3. Same goes for the right side, but we will be doing channel 2. Now this is a very similar format to our simple autonomous mode we wrote earlier. The convenient thing here is the joysticks go from -127 to +127, and when they're resting up and down, they're 0. So if you push on the joystick, it will go from 0 to 127 if you're pushing up, or -127 when you're pushing downward. With just these few lines of code, we've created a robot that will drive. If we want to use the bumper on the left side to control the left motors, we would do the same thing, but instead of channels, we will use button, BTN, and we'll use 5U. So that's the top 5, that's the top button on the left-hand side. Now if we were to run this, just like this, the motor would barely move at all. In fact, you probably wouldn't notice it, because buttons are 0 when not pressed and 1 when they are pressed. And if we set them equal to this, you're just setting the motor equal to 1, which is very, very low power. So what we're going to have to do is multiply it by 127. So what this will do is when you press the button, it'll go full power. You can set this value to whatever you want, but I want it to run at full power. Now if I want to reverse that motor with a button, I will have to do minus vex RT button 5D. I also will multiply this one by 127. So what this is saying is I want the value of the motor to be a +127 full power if I click up, and I want it to go full power reverse if I click the down button. You can use the same syntax to apply to any motor you want. Now if you want to run motors off a second controller, you do the same thing, except the channel will be whatever channel or button you want, but XMRT2 on the end. This just says transmitter 2, your second controller. So there you go. Those are the very basics of RobotC. If you have any questions, leave them in the comments section below. Like it if you like this tutorial, and next time we'll be talking about if-else logic statements.